Question 1. Governance review demonstrates that a critical service provider network segment is experiencing a widespread outage impacting multiple enterprise customers. The network engineering team has identified a potential workaround that involves temporarily disabling a specific security feature, which is known to be a compliance requirement for data integrity and audit logging under relevant U.S. federal regulations. Management is pressuring the engineer to restore service immediately, suggesting the security feature can be re-enabled later. What is the most appropriate course of action for the network engineer? Option A. Escalate the issue to the Security Operations Center and management, clearly outlining the technical solution, its compliance implications, and requesting an authorized exception or alternative compliance solution. Option B. Immediately implement the workaround to restore service, documenting the change and planning to re-enable the security feature as soon as possible. Option C. Refuse to implement any solution that deviates from current security policies and regulatory mandates, regardless of the business impact. Option D. Implement a different, less effective workaround that does not involve disabling the security feature, but will take significantly longer to deploy and may not fully restore service. Correct answer is B. Immediately implement the workaround to restore service, documenting the change and planning to re-enable the security feature as soon as possible. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in network operations, where a perceived immediate business need conflicts with established security policies and potential regulatory compliance. The challenge lies in balancing the urgency of service restoration with the responsibility to maintain network integrity and adhere to security best practices. The network engineer is under pressure from management to resolve a critical outage, but doing so might involve bypassing security controls that are in place for compliance and risk mitigation. The decision requires careful judgment to avoid compromising security, violating regulations, or creating future vulnerabilities. Correct approach analysis. The correct approach prioritizes adherence to established security policies and regulatory frameworks. In the context of Cisco service provider networks, this often involves compliance with data privacy regulations, e.g., GDPR if applicable to the service provider's customer base, though the exam jurisdiction is U.S.-centric. U.S. regulations like HIPAA for healthcare data or PCI DSS for payment card data will be more relevant if the service provider handles such traffic. Network security standards, e.g., NIST frameworks, and internal governance policies. The correct approach involves escalating the issue to the appropriate security and management teams, documenting the situation, and seeking authorized exceptions or alternative compliance solutions. This upholds the principle of least privilege, ensures accountability, and maintains the integrity of security controls, which are often mandated by regulatory bodies. It demonstrates professional responsibility by not taking shortcuts that could lead to breaches or non-compliance. Incorrect approach is analysis. An incorrect approach would be to directly implement the proposed workaround without proper authorization or assessment. This bypasses established security protocols, potentially violating network security policies and any relevant U.S. regulations that mandate specific security controls for data protection or network resilience. For instance, if the workaround involves disabling logging or intrusion detection systems, it would directly contravene requirements found in frameworks like NIST SB 800-53 or specific industry regulations like HIPAA security rule, which mandate audit trails and security monitoring. Such an action could lead to significant fines, reputational damage, and loss of customer trust. Another incorrect approach would be to delay the resolution indefinitely due to strict adherence to policy without seeking any form of exception or alternative. While adhering to policy is crucial, an absolute refusal to consider any deviation, even under extreme circumstances and without escalation, can be detrimental to business operations and customer service, potentially leading to breaches of service-level agreements, SLAs, which themselves might have regulatory implications depending on the industry. However, the primary failure here is not seeking an authorized path for resolution. A third incorrect approach might involve implementing a solution that technically resolves the outage, but introduces new, undocumented security risks or fails to meet compliance requirements. This could involve using unapproved software, hardware, or configuration changes that are not vetted by the security team, thereby creating a blind spot in the network's security posture and potentially violating compliance mandates that require documented and approved network changes. Professional reasoning. Professionals in network operations must adopt a decision-making process that prioritizes security and compliance while acknowledging business needs. This involves 1. Understanding the immediate impact and urgency of the situation. 2. Consulting relevant security policies, network architecture documentation, and applicable regulatory requirements. 3. Identifying potential solutions and assessing their security and compliance implications. 4. Escalating the issue to appropriate stakeholders, e.g., security operations management, compliance officers, to discuss risks and explore authorized workarounds or exceptions. 5. Documenting all actions, decisions, and communications thoroughly. 6. Implementing approved solutions with proper oversight and post-implementation verification. This structured approach ensures that critical business functions are restored responsibly, without compromising the organization's security posture or regulatory standing. Question 2. Quality control measures reveal that a critical network device in the service provider's core infrastructure is exhibiting intermittent packet loss, impacting a significant customer segment. The network engineer on duty identifies a potential configuration error that could be the cause. However, the standard change management process requires a 24-hour approval window, which would extend the customer impact. The engineer has the technical expertise to correct the configuration immediately, but is aware that bypassing the formal change control process is a violation of company policy and could have security implications. What is the most appropriate course of action for the engineer? Option A. Escalate the issue to the network operations manager and security team, requesting an expedited emergency change authorization to correct the configuration error. While providing detailed impact analysis, Option B. Immediately implement the configuration change to restore service, and then submit the change request for retrospective approval, documenting the emergency nature of the fix. Option C. Advise customers that there is a known issue and that service may be intermittent for the next 24 hours while the change control process is followed. Option D. Proceed with the configuration change without informing anyone, as restoring customer service is the highest priority and the fix is straightforward. The correct answer is B. Immediately implement the configuration change to restore service, and then submit the change request for retrospective approval, documenting the emergency nature of the fix. Explanation. This scenario presents a professional challenge because it involves a conflict between immediate operational needs and long-term security and compliance. The service provider is under pressure to restore service quickly, but doing so without proper authorization or adherence to established security protocols could have significant repercussions. The core of the challenge lies in balancing the urgency of customer impact with the imperative to maintain network integrity and comply with regulatory frameworks. The correct approach represents best professional practice because it prioritizes adherence to established change management and security policies, even under pressure. This aligns with the principles of responsible network operation and compliance with industry standards and potentially regulatory mandates for service providers. By escalating the issue through the proper channels and seeking explicit authorization for an emergency change, the engineer demonstrates a commitment to due diligence, risk mitigation, and maintaining an auditable trail of critical network modifications. This proactive stance protects the organization from potential security breaches, service disruptions caused by unauthorized changes, and regulatory penalties. An incorrect approach that involves bypassing established change control procedures to quickly restore service is professionally unacceptable. This action represents a significant ethical and regulatory failure. It undermines the integrity of the network's security posture by introducing unvetted changes, potentially creating new vulnerabilities or exacerbating existing ones. From a regulatory standpoint, many jurisdictions have specific requirements for network change management and incident response for critical infrastructure providers. Failing to follow these procedures can lead to non-compliance, fines, and reputational damage. It also sets a dangerous precedent, encouraging a culture of cutting corners that can have cascading negative effects on overall network stability and security. Another incorrect approach, which is to ignore the issue and hope it resolves itself, is also professionally unacceptable. This demonstrates a lack of accountability and proactive problem solving. It fails to address the root cause of the problem, leaving customers without service and potentially allowing a minor issue to escalate into a major outage. Ethically, service providers have a responsibility to their customers to maintain reliable service. Ignoring a known issue violates this responsibility and can lead to customer dissatisfaction and loss of business. A third incorrect approach, which is to implement a temporary fix without documenting it or planning for a permanent solution, is also problematic. While it might restore service, it creates technical debt and introduces an undocumented state into the network. This makes future troubleshooting more difficult, increases the risk of unexpected behavior, and can hinder compliance audits. It also fails to address the underlying cause, meaning the problem is likely to recur. Professional reasoning process for this situation should involve a clear understanding of the organization's change management policies, security protocols, and any relevant regulatory requirements. When faced with an urgent issue, the first step is to assess the impact and urgency. Then, consult the established procedures for emergency changes. If an emergency change is warranted, it must be documented, approved through the expedited process, if available, and implemented with strict adherence to security best practices. If the situation deviates from established procedures, escalation to management and relevant security teams is crucial. The decision-making framework should prioritize risk assessment, adherence to policy, and clear communication throughout the incident resolution process. Question 3. Implementation of a new service provider network core technology is experiencing intermittent packet loss and increased latency, impacting customer experience. The network engineer suspects a configuration issue but is under pressure to restore optimal performance immediately. The vendor's support team has been engaged but is slow to respond. The engineer has identified a potential configuration parameter that, if adjusted, might alleviate the symptoms, but the exact impact of this adjustment is not fully understood, and it deviates from standard best practices for this platform. Which of the following represents the most professionally responsible course of action? Option A. Escalate the issue to management, requesting additional resources or vendor prioritization, and continue to gather detailed telemetry and logs to build a comprehensive case for the vendor's urgent attention. While exploring alternative, documented troubleshooting steps, Option B. Proceed with the configuration adjustment that is believed to alleviate the symptoms, documenting the change as a temporary measure to restore service, and plan for a full root cause analysis once the immediate pressure subsides. Option C. Implement the configuration adjustment that is believed to alleviate the symptoms without further consultation or documentation, prioritizing immediate service restoration over thorough analysis. Option D. Advise management that the issue is complex and requires significant time for root cause analysis, potentially leading to extended service degradation, and suggest a rollback to a previous stable configuration if feasible. The correct answer is B. Proceed with the configuration adjustment that is believed to alleviate the symptoms, documenting the change as a temporary measure to restore service, and plan for a full root cause analysis once the immediate pressure subsides. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain network integrity and customer trust while facing pressure to meet performance metrics. The core dilemma lies in balancing the immediate need for service availability with the long-term implications of potentially compromising network security or stability for short-term gains. The service provider's reputation and customer satisfaction are at stake, making a decision that prioritizes expediency over sound engineering principles highly risky. Correct approach analysis. The correct approach involves a thorough, documented investigation into the root cause of the performance degradation. This aligns with best professional practices and the implicit ethical duty to provide reliable and secure services. By engaging the vendor for a joint troubleshooting effort, the engineer adheres to established support channels and leverages expert knowledge, ensuring that any resolution is technically sound and does not introduce new vulnerabilities. This methodical approach upholds the principles of due diligence and responsible network management, safeguarding the network and customer experience. It also ensures that any changes made are traceable and justifiable, crucial for compliance and future audits. Incorrect approach is analysis. Implementing a configuration change without full understanding or vendor validation poses significant risks. This approach bypasses established troubleshooting protocols and could lead to unintended consequences, such as network instability, security breaches, or further performance issues. Ethically, it violates the duty of care to the customer and the employer by acting without sufficient expertise or authorization, potentially causing harm. Ignoring the issue and hoping it resolves itself is a dereliction of professional duty. It fails to address the underlying problem, which could escalate and lead to more severe service disruptions. This passive approach erodes customer confidence and demonstrates a lack of commitment to service quality, which is a fundamental ethical failing in the service provider industry. Applying a quick fix that masks the symptom without addressing the root cause is also professionally unsound. While it might temporarily alleviate the immediate pressure, it leaves the network vulnerable to recurring issues and potential future failures. This approach prioritizes short-term appearances over long-term network health and reliability, which is ethically questionable as it does not represent a sustainable or responsible solution. Professional reasoning. Professionals in network engineering must adopt a systematic and ethical decision-making process. This involves 1. Problem identification and assessment. Clearly define the issue and its potential impact. 2. Information gathering. Collect all relevant data, logs, and performance metrics. 3. Root cause analysis. Employ structured troubleshooting methodologies to identify the fundamental reason for the problem. 4. Solution evaluation. Assess potential solutions for their technical feasibility, security implications, and long-term impact. 5. Consultation and collaboration. Engage with vendors, colleagues, and management as appropriate, especially for complex or critical issues. 6. Implementation and verification. Execute the chosen solution with proper change control and thoroughly test to confirm resolution and absence of adverse effects. 7. Documentation. Maintain detailed records of the problem, troubleshooting steps, and resolution. This framework ensures that decisions are informed, responsible, and aligned with professional ethics and organizational policies. Question 4. The risk matrix shows a critical incident impacting core routing services. The network engineer has identified a potential configuration change that could resolve the issue, but has not yet tested it in a lab environment and has not received formal change approval. The engineer is considering applying the change directly to the production network to restore service as quickly as possible. Option A. Document all possible scenarios and their potential outcomes in extreme detail before attempting any intervention, prioritizing comprehensive analysis over immediate action. Option B. Engage the incident management team, consult the risk matrix for detailed impact analysis, and proceed with a documented risk-assessed remediation plan, which may include lab testing and change approval if time permits and risk analysis dictates. Option C. Immediately apply the identified configuration change to the production network to restore service without delay, as speed is paramount in critical incidents. Option D. Rely solely on pre-approved automated remediation scripts to resolve the issue, assuming they are designed to handle all critical routing failures. The correct answer is B. Engage the incident management team, consult the risk matrix for detailed impact analysis, and proceed with a documented, risk-assessed remediation plan, which may include lab testing and change approval if time permits and risk analysis dictates. Explanation. This scenario presents a common challenge in service provider network operations, balancing the need for rapid incident resolution with the imperative to maintain network stability and adhere to established change management processes. The professional challenge lies in the inherent tension between urgency and control. A critical incident demands immediate action, but uncontrolled or poorly planned interventions can exacerbate the problem, leading to wider outages, data corruption, or security breaches. This requires a nuanced judgment call, informed by risk assessment and a clear understanding of the potential consequences. The correct approach represents best professional practice because it prioritizes a structured, risk-informed response. By engaging the incident management team and leveraging the existing risk matrix, the network engineer is adhering to established protocols designed to mitigate further damage. This systematic approach ensures that all potential impacts are considered, including downstream services, customer experience, and compliance requirements. The decision to escalate and involve relevant stakeholders before implementing a potentially disruptive fix aligns with the principles of responsible network management, emphasizing collaboration and informed decision-making. This proactive engagement minimizes the likelihood of unintended consequences and ensures that the resolution is both effective and sustainable. An incorrect approach that involves immediately attempting a complex, unverified fix without proper authorization or assessment is professionally unacceptable. This bypasses critical control points designed to prevent widespread issues, Such an action could lead to a cascade failure, impacting a larger customer base and potentially violating service-level agreements, SLAs. From a regulatory and ethical standpoint, this demonstrates a disregard for established operational procedures and a failure to exercise due diligence. It prioritizes individual action over collective responsibility and risk management, which can have severe financial and reputational consequences for the service provider. Another incorrect approach, such as delaying action to meticulously document every potential scenario before any intervention, is also professionally flawed. While documentation is important, excessive delay in the face of a critical incident can lead to prolonged service disruption, customer dissatisfaction, and potential financial penalties. This approach fails to strike a balance between thoroughness and timeliness, demonstrating an inability to adapt to the dynamic nature of incident response. Ethically, it can be seen as a failure to act with reasonable promptness when a critical service is impacted. A third incorrect approach, such as relying solely on automated remediation scripts without human oversight for a complex, novel issue, is also problematic. While automation is valuable, it assumes that the script is perfectly designed for the specific, emergent problem. Without human judgment to validate the script's applicability and monitor its execution in real time, there's a significant risk of the automation exacerbating the issue or causing new problems. This demonstrates a lack of critical thinking and an over-reliance on technology without considering its limitations in unforeseen circumstances, which is a failure in professional responsibility. The professional decision-making process for similar situations should involve a rapid assessment of the incident's impact and urgency. This includes consulting the risk matrix to understand the severity and potential scope of the problem. The next step is to engage the appropriate incident management team and stakeholders, communicating the situation clearly and concisely. Based on the collective assessment and available information, a decision should be made regarding the most appropriate course of action, which may involve immediate containment, a controlled remediation, or further investigation. Throughout this process, maintaining clear communication and documenting actions taken are paramount. Question 5. The control framework reveals a persistent issue with suboptimal traffic flow and occasional congestion points within the service provider's core network. To address this, which of the following strategies represents the most effective and professionally sound approach to process optimization? Option A. Conduct a series of broad, network-wide configuration changes based on recent industry white papers, assuming these will universally improve traffic flow and resolve congestion. Option B. Focus solely on reducing operational costs by deprovisioning underutilized network hardware without a detailed analysis of its impact on peak traffic capacity and redundancy. Option C. Implement a comprehensive network monitoring and analytics solution to collect granular telemetry data, analyze traffic patterns, identify specific congestion points and performance anomalies, and then use this data to inform targeted adjustments to routing policies, traffic engineering parameters, and resource allocation. Option D. Rely on manual intervention and ad hoc troubleshooting whenever congestion is reported by customers, without establishing a proactive system for identifying and resolving potential issues. The correct answer is C. Implement a comprehensive network monitoring and analytics solution to collect granular telemetry data, analyze traffic patterns, identify specific congestion points and performance anomalies, and then use this data to inform targeted adjustments to routing policies, traffic engineering parameters, and resource allocation. Explanation. The control framework reveals a critical need to optimize the operational efficiency of a service provider's core network. This scenario is professionally challenging because the pressure to maintain high availability and performance, coupled with the complexity of modern service provider networks, often leads to reactive rather than proactive optimization strategies. Decisions must balance immediate service delivery demands with long-term network health and cost-effectiveness, all while adhering to strict operational guidelines and potential service-level agreements, SLAs. The correct approach involves a systematic, data-driven methodology for process optimization. This entails leveraging network telemetry and analytics to identify bottlenecks, predict potential failures, and automate routine tasks. By focusing on proactive tuning of routing protocols, traffic engineering, and resource allocation based on observed traffic patterns and performance metrics, the service provider can achieve sustained improvements in throughput, latency, and overall network stability. This aligns with best professional practices by ensuring that network operations are not only efficient, but also resilient and cost-effective, directly contributing to customer satisfaction and meeting SLA commitments. Furthermore, such a data-driven approach supports auditability and compliance by providing clear evidence of operational decisions and their impact. An incorrect approach would be to implement broad, untested configuration changes across the network without granular analysis. This could lead to unintended consequences, service disruptions, and increased troubleshooting overhead, directly violating the principle of maintaining network stability and potentially breaching SLAs. Another incorrect approach is to solely rely on vendor default configurations or outdated best practices without considering the specific traffic patterns and growth of the service provider's network. This failure to adapt and optimize for the unique operational environment represents a significant lapse in professional due diligence and can lead to suboptimal performance and increased operational costs. Lastly, prioritizing cost reduction through aggressive resource provisioning without a thorough impact assessment on performance and capacity is a critical failure. This reactive cost-cutting measure, without understanding its implications on service delivery, is professionally irresponsible and ethically questionable, as it directly jeopardizes service quality and customer trust. Professionals should adopt a decision-making framework that emphasizes continuous monitoring, data analysis, and iterative improvement. This involves establishing clear performance baselines, defining key performance indicators, KPI for network operations, and regularly reviewing network telemetry to identify areas for optimization. When considering any change, a thorough impact assessment, including simulation or staged rollout, should be conducted. This systematic approach ensures that optimization efforts are targeted, effective, and minimize the risk of negative repercussions, fostering a culture of proactive network management and operational excellence. Question 6. Strategic planning requires a proactive approach to network operations that anticipates potential issues and fosters continuous improvement. When faced with a customer-impacting network incident, what is the most effective strategy for addressing the immediate problem while also enhancing long-term operational efficiency? Option A. Deploy a temporary workaround and consider it a permanent solution if it stabilizes the network, avoiding the overhead of a full root cause analysis. Option B. Implement a temporary workaround to restore service immediately, document the incident for future reference, and initiate a root cause analysis to develop a permanent solution and optimize the underlying process. Option C. Immediately escalate the incident to the highest possible support tier without performing any initial diagnostics or documentation. Option D. Apply a quick fix that restores service, and then move on to the next priority without further investigation, assuming the issue will not recur. The correct answer is B. Implement a temporary workaround to restore service immediately, document the incident for future reference, and initiate a root cause analysis to develop a permanent solution and optimize the underlying process. Explanation. Scenario analysis. This scenario presents a common challenge in service provider network operations, balancing the immediate need for service restoration with the long-term strategic goal of process optimization. The pressure to resolve a customer-impacting outage quickly can lead to expedient, but potentially suboptimal, workarounds. This creates a professional dilemma where immediate operational demands conflict with the principles of efficient and sustainable network management. The challenge lies in making a decision that addresses the immediate crisis while also laying the groundwork for future improvements, avoiding the creation of technical debt or recurring issues. Correct approach analysis. The correct approach involves a structured incident response that includes immediate mitigation, followed by a root cause analysis and subsequent process improvement. This aligns with best practices in IT service management ITSM, such as those outlined in ITIL frameworks, which are implicitly expected in professional Cisco certifications. By documenting the incident, analyzing the root cause, and then implementing a permanent fix that also optimizes the underlying process, the organization not only resolves the current issue, but also enhances its overall operational efficiency and resilience. This proactive stance minimizes the likelihood of similar incidents recurring, improves mean time to repair, MTTR, for future events, and contributes to a more stable and reliable network service, which is a core tenet of service provider operations. This approach demonstrates a commitment to continuous improvement and operational excellence. Incorrect approaches analysis. Implementing a temporary workaround without a plan for permanent resolution creates technical debt. This is professionally unsound because it addresses the symptom, not the cause, leading to potential future failures, increased complexity, and higher maintenance costs. It fails to uphold the responsibility of ensuring network stability and reliability. Focusing solely on restoring service without any form of documentation or analysis is a failure to learn from incidents. This approach is ethically questionable, as it neglects the opportunity to improve processes and prevent future disruptions, potentially impacting customer trust and service-level agreements. It demonstrates a lack of professional diligence in managing network infrastructure. Escalating the issue to a higher tier of support without attempting any initial troubleshooting or analysis is inefficient and bypasses opportunities for skill development and knowledge sharing within the team. While escalation is sometimes necessary, doing so prematurely without due diligence can be seen as a failure to take ownership and can prolong resolution times, impacting service availability. Professional reasoning. Professionals should approach such situations by first prioritizing customer impact and service restoration. However, this immediate action must be coupled with a commitment to understanding the root cause. A structured incident management process, including clear documentation, post-incident review, and a plan for permanent remediation and process improvement, is essential. This framework ensures that lessons are learned, operational efficiency is enhanced, and the network's long-term health is maintained. The decision-making process should always consider the balance between immediate needs and strategic objectives for continuous improvement. Question 7. Assessment of a proposed BGP route filtering policy for a new customer service integration. A network engineer is tasked with implementing the necessary BGP route filters. The engineer has received the customer's requested prefix advertisement list and a basic filtering template from the vendor. The business unit is pushing for rapid deployment to meet a critical deadline. What is the most professional and secure approach to implementing these BGP route filters? Option A. Implement the BGP route filtering policy after a thorough review against the service provider's established security policies, operational guidelines, and best practices for BGP route security, ensuring it prevents unauthorized prefix advertisements and protects against common BGP threats. Option B. Implement the BGP route filtering policy based solely on the customer's requested prefix advertisement list, without cross-referencing against internal policies or security best practices. Option C. Immediately implement the BGP route filtering policy as provided by the vendor, assuming it offers sufficient protection for the new service integration. Option D. Implement the BGP route filtering policy with minimal filtering, focusing only on the customer's explicitly provided prefixes, with the understanding that any issues can be addressed reactively after deployment. The correct answer is A. Implement the BGP route filtering policy after a thorough review against the service provider's established security policies, operational guidelines, and best practices for BGP route security, ensuring it prevents unauthorized prefix advertisements and protects against common BGP threats. Explanation. Scenario analysis. This scenario presents a common challenge in service provider networks where the rapid deployment of new services, driven by business demands, can outpace thorough security and compliance validation. The core challenge lies in balancing the need for agility and service innovation with the imperative to maintain network integrity and adhere to established security policies and potentially regulatory mandates. Though specific regulations are not detailed here, the principle of adherence to internal and industry best practices is paramount. The pressure to deliver a new service quickly can lead to shortcuts in testing, documentation, and security reviews, creating vulnerabilities. Correct approach analysis. The correct approach prioritizes a comprehensive review of the proposed BGP route filtering policy against established security best practices and the service provider's own documented operational guidelines. This involves verifying that the filters are granular enough to prevent the advertisement of unauthorized prefixes, protect against route injection attacks, and align with the provider's peering agreements and traffic engineering objectives. This methodical approach ensures that the new service integration does not introduce unintended security risks or operational instability. Representing best professional practice, by adhering to a robust change management and security validation process. Incorrect approaches analysis. One incorrect approach involves immediately implementing the BGP route filtering policy without any prior review. This is professionally unacceptable because it bypasses critical security and operational checks. It directly violates the principle of due diligence in network changes, potentially exposing the network to route hijacking, prefix hijacking, or the advertisement of invalid routes, which can disrupt services for customers and partners. This approach demonstrates a disregard for established change control procedures and security best practices. Another incorrect approach is to implement the policy based solely on the vendor's default configuration recommendations. While vendor defaults can be a starting point, they are rarely optimized for a specific service provider's unique network environment, security posture, or business requirements. Relying solely on defaults without customization and validation is a failure to apply professional judgment and can lead to suboptimal security or operational performance, leaving the network vulnerable to threats that default configurations do not address. A third incorrect approach is to implement the policy with minimal filtering, assuming that any issues can be addressed reactively. This reactive stance is professionally unsound. In network operations, proactive security measures are far more effective and less costly than reactive incident response. Implementing insufficient filtering increases the attack surface and the likelihood of a security incident, which can have severe consequences for the service provider and its customers. It demonstrates a lack of foresight and a failure to prioritize network security. Professional reasoning. Professionals should approach network changes, especially those involving core routing protocols like BGP, with a structured and risk-aware methodology. This involves 1. Understanding the business requirement and its technical implications. 2. Consulting and adhering to established network design principles, security policies, and operational guidelines. 3. Performing thorough impact analysis and risk assessment. 4. Developing a detailed implementation plan, including rollback procedures. 5. Conducting rigorous testing in a lab environment or during a scheduled maintenance window. 6. Documenting all changes and their rationale. This systematic process ensures that changes are implemented safely, securely, and effectively, minimizing disruption and risk. Question 8. What factors determine the appropriate balance between the urgency of deploying new service provider network features and the necessity of ensuring comprehensive security and regulatory compliance during the implementation process? Option A. The personal technical expertise of the lead network engineer responsible for the deployment. Option B. The availability of network hardware that supports the new feature, regardless of security implications. Option C. The thoroughness of the risk assessment, the clarity of the regulatory requirements, and the established change management procedures. Option D. The perceived competitive advantage gained by being the first to market with the new feature. The correct answer is C. The thoroughness of the risk assessment, the clarity of the regulatory requirements, and the established change management procedures. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid service deployment and the need for robust security and compliance within a service provider network. The core of the challenge lies in balancing the business imperative of delivering new services quickly to market with the regulatory and operational requirements that ensure network integrity, customer data protection, and service availability. Careful judgment is required to avoid compromising security or compliance for the sake of speed, which could lead to significant financial penalties, reputational damage, and loss of customer trust. The correct approach represents best professional practice because it prioritizes a structured, risk-aware methodology that integrates security and compliance from the outset. This aligns with the principles of security by design and compliance by design, which are fundamental to operating within regulated environments. By involving relevant stakeholders early, conducting thorough impact assessments, and adhering to established change management processes, the organization minimizes the risk of introducing vulnerabilities or non-compliance issues. This proactive stance is crucial for maintaining a secure and reliable service provider network, which is a core tenet of the SPCOR. Exams focus on operational excellence and adherence to industry best practices. An incorrect approach that focuses solely on speed without adequate security and compliance vetting would represent a significant regulatory and ethical failure. This could violate data privacy regulations, GDPR if applicable to the jurisdiction, though for this exam we assume a U.S.-centric framework where relevant data protection laws apply, service level agreements, SLAs, and internal security policies. Such an approach demonstrates a disregard for the potential harm to customers and the business, leading to potential breaches, service disruptions, and legal repercussions. Another incorrect approach that prioritizes technical feasibility over business and user impact would also be professionally unacceptable. While technically sound, it might overlook critical business requirements, user experience considerations, or the broader operational implications of the new service. This can lead to a solution that is technically elegant but ultimately fails to meet the needs of the business or its customers, resulting in wasted resources and missed opportunities. A professional decision-making process for similar situations should involve a multifaceted risk assessment. This includes identifying potential technical risks, security vulnerabilities, compliance gaps, and business impacts. It requires engaging a diverse group of stakeholders, including network engineers, security teams, compliance officers, and business unit representatives, to gather comprehensive input. A structured change management process, including thorough testing, documentation, and rollback plans, is essential. Ultimately, the decision should be guided by a clear understanding of the organization's risk appetite, regulatory obligations, and strategic objectives, ensuring that new service deployments are both timely and secure. Question 9. When evaluating the operational readiness for a new segment routing (SR) implementation using an MPLS data plane within a service provider network, which approach best ensures that network operations teams are adequately prepared to monitor, troubleshoot, and manage the new technology effectively, thereby minimizing service impact and maintaining operational integrity? Option A. Provide the network operations teams with the vendor's standard SR documentation and conduct a single, high-level overview presentation on the technology's benefits. Option B. Proceed with the SR implementation and expect the network operations teams to learn the technology through on-the-job experience and by consulting generic vendor documentation as issues arise. Option C. Conduct comprehensive, role-specific training sessions for network operations teams, develop tailored operational runbooks and troubleshooting guides for SR, and establish a collaborative validation process with these teams before and during the full rollout. Option D. Implement SR in a limited scope and only provide training to a select group of senior engineers, assuming they will disseminate knowledge to the broader operations team as needed. Correct answer is C. Conduct comprehensive, role-specific training sessions for network operations teams, develop tailored operational runbooks and troubleshooting guides for SR, and establish a collaborative validation process with these teams before and during the full rollout. Explanation. Scenario analysis. This scenario presents a common challenge in service provider networks where the introduction of new technologies, like segment routing (SR) with MPLS data plane, impacts existing operational processes and stakeholder expectations. The challenge lies in balancing the technical benefits of SR, simplified routing, traffic engineering, with the operational readiness and understanding of the teams responsible for monitoring, troubleshooting, and managing the network. Failure to adequately prepare these stakeholders can lead to increased incident resolution times, misinterpretations of network behavior, and a lack of confidence in the new technology, ultimately hindering its successful adoption and potentially impacting service-level agreements, SLAs. The need for a proactive and inclusive approach is paramount. Correct approach analysis. The correct approach involves a comprehensive stakeholder engagement strategy that prioritizes education, clear communication, and collaborative validation. This includes providing detailed technical documentation tailored to different stakeholder groups, conducting hands-on training sessions, and establishing a joint validation process for the SR implementation. This aligns with best practices in project management and technology deployment, ensuring that all relevant parties are equipped with the necessary knowledge and have a shared understanding of the technology's behavior and operational impact. From a regulatory and ethical standpoint, this approach demonstrates a commitment to transparency and due diligence, ensuring that service delivery is not compromised due to a lack of preparedness. It fosters trust and accountability among teams, which is crucial for maintaining operational integrity and meeting customer commitments. Incorrect approaches analysis. One incorrect approach is to proceed with the SR implementation without adequate stakeholder training or communication, assuming that the operations teams will adapt independently. This represents a significant ethical failure as it disregards the professional development and operational readiness of the teams, potentially leading to service disruptions and an inability to meet SLAs. It also creates an environment where troubleshooting becomes reactive and inefficient, increasing the risk of prolonged outages. Another incorrect approach is to solely rely on vendor-provided documentation without contextualizing it for the specific network environment and operational workflows. While vendor documentation is a valuable resource, it often lacks the specific details required for day-to-day operations within a particular service provider's infrastructure. This approach fails to address the unique challenges and nuances of the deployed network, leading to a gap in practical understanding and potentially misapplication of the technology. Ethically, this can be seen as a failure to adequately equip internal resources, leading to potential errors and service degradation. A third incorrect approach is to limit communication to high-level summaries without providing the necessary technical depth for operational teams. This can lead to a superficial understanding of SR, where the benefits are acknowledged but the underlying mechanisms and troubleshooting techniques remain obscure. This lack of detailed understanding can be detrimental during critical incidents, preventing effective problem diagnosis and resolution. It also undermines the confidence of operational staff in their ability to manage the new technology, creating a bottleneck for future network evolution. Professional reasoning. Professionals should adopt a phased approach to technology deployment that includes robust stakeholder analysis and engagement. This involves identifying all affected parties, understanding their current knowledge base and operational responsibilities, and developing a tailored communication and training plan. The decision-making process should prioritize proactive risk mitigation by ensuring that all teams are adequately prepared before and during the implementation. This involves establishing clear lines of communication, providing accessible and relevant resources, and fostering a collaborative environment for validation and feedback. When faced with new technologies, professionals must ask, who needs to know about this? What do they need to know? And how can we best equip them to succeed? This ensures that technical advancements are supported by operational excellence and ethical responsibility. Question 10. Process analysis reveals that a service provider is considering the implementation of segment routing, SR, with MPLS data planes to enhance network efficiency and simplify its core architecture. The operations team, accustomed to traditional MPLS LDP, has expressed concerns about the learning curve and potential operational complexities. Which approach best balances the technical benefits of SR with the operational readiness of the team and ensures a smooth transition? Option A. Prioritize the immediate technical deployment of SR to realize its benefits quickly, assuming the operations team can adapt to the new protocols through on-the-job learning. Option B. Deploy SR in a piecemeal fashion across different network segments without a unified communication strategy or clear rollback plan, allowing the operations team to discover operational nuances organically. Option C. Focus solely on the cost-saving aspects of SR, deferring any significant training or operational procedure updates until issues arise post-implementation. Option D. Implement SR with a comprehensive training program for the operations team, develop updated operational runbooks, and conduct pilot deployments to validate operational procedures before a full rollout. The correct answer is D. Implement SR with a comprehensive training program for the operations team, develop updated operational runbooks, and conduct pilot deployments to validate operational procedures before a full rollout. Explanation. Scenario analysis. This scenario presents a common challenge in service provider networks where the implementation of new technologies, such as segment routing, SR, with MPLS data planes, directly impacts the operational efficiency and service delivery capabilities. The challenge lies in balancing the technical benefits of SR, simplified network architecture, improved traffic engineering, with the potential disruption to existing operational processes and the need for stakeholder buy-in. Failure to adequately address stakeholder concerns can lead to project delays, resistance to adoption, and ultimately, suboptimal implementation that doesn't realize the full potential of the technology. The core of the challenge is managing the transition from a familiar operational paradigm to a new one, ensuring that all affected parties understand the implications and are equipped to handle the changes. Correct approach analysis. The correct approach involves a proactive and comprehensive stakeholder engagement strategy. This includes clearly communicating the technical advantages of SR, such as reduced complexity and enhanced traffic engineering capabilities, and demonstrating how these benefits translate into improved service quality and operational efficiency for the business. Crucially, it involves providing thorough training and developing updated operational procedures that align with the new SR architecture. This ensures that the operations team is not only aware of the changes, but also competent in managing the network under the new paradigm. This approach represents best professional practice because it prioritizes a smooth transition, minimizes operational risks, and maximizes the return on investment by ensuring the technology is effectively utilized. It aligns with the general principles of project management and change management, which are implicitly expected in professional IT environments, ensuring that technology adoption is driven by business needs and supported by operational readiness. Incorrect approaches analysis. One incorrect approach involves prioritizing the technical implementation of SR without adequately preparing the operations team. This leads to operational challenges, increased troubleshooting time, and potential service disruptions. Ethically, this fails to uphold the responsibility to ensure operational stability and service continuity. It also demonstrates a lack of foresight in project execution, potentially leading to reputational damage for the IT department. Another incorrect approach is to focus solely on the cost savings associated with SR, neglecting the operational impact and the need for training. While cost efficiency is important, it should not come at the expense of operational capability. This approach can be seen as short-sighted and potentially unethical if it leads to a situation where the network cannot be reliably managed, impacting customer service. A third incorrect approach is to implement SR in a phased manner without clear communication or defined rollback plans. This can create confusion among the operations team, leading to inconsistent network behavior and difficulty in diagnosing issues. It also fails to provide a clear roadmap for adoption, hindering the overall success of the initiative. This approach lacks the structured planning and communication essential for complex technology deployments. Professional reasoning. Professionals should adopt a structured approach to technology implementation that prioritizes stakeholder needs and operational readiness. This involves a thorough understanding of the technology's impact on existing processes, comprehensive risk assessment, and a robust change management plan. The decision-making process should be guided by principles of effective communication, proactive training, and a commitment to ensuring the operational stability and service quality of the network. When evaluating different implementation strategies, professionals should ask, does this approach ensure that our operations team is fully equipped to manage the network effectively post-implementation? And does this approach align with our commitment to delivering reliable services to our customers? Question 11. Performance analysis shows that a large service provider is experiencing increased latency and slower convergence times in its core network during peak traffic hours. The current routing protocol, while functional, is struggling to adapt to the dynamic nature of the network topology and the growing number of routes. The service provider needs to upgrade its core routing protocol to ensure high availability and efficient traffic management. Which routing protocol is the most appropriate choice for the core of a large service provider network to address these challenges? Option A, Enhanced Interior Gateway Routing Protocol (IGAP). Option B, Routing Information Protocol (RIP). Option C, Open Shortest Path First (OSPF). Option D, Border Gateway Protocol (BGP). The correct answer is D, Border Gateway Protocol (BGP). Explanation. This scenario presents a professional challenge in a service provider network environment where the efficient and reliable delivery of services is paramount. The challenge lies in selecting the most appropriate routing protocol for a large-scale dynamic service provider core network, balancing factors like convergence time, scalability, and resource utilization. Careful judgment is required to avoid service disruptions, ensure optimal network performance, and maintain compliance with operational best practices. The correct approach involves selecting a routing protocol that is specifically designed for the complexities and scale of service provider core networks, such as BGP. BGP is the de facto standard for interdomain routing and is highly scalable, robust, and offers granular control over routing policies, which are essential for service providers to manage traffic engineering, peering agreements, and customer routes effectively. Its ability to handle a vast number of routes and its extensibility make it the most suitable choice for the core of a service provider network, aligning with industry best practices for core network design and operation. An incorrect approach would be to select a routing protocol not designed for the scale and operational requirements of a service provider core, such as OSPF or IGAP. Using OSPF in a service provider core would lead to significant scalability issues due to its link-state nature and the sheer number of routes and adjacencies that would need to be managed. This could result in excessive CPU and memory utilization on routers, slow convergence times, and potential instability, directly impacting service availability. Ethically, deploying a protocol that is known to be inadequate for the intended environment represents a failure to uphold professional responsibility for ensuring reliable service delivery. Similarly, IGAP, while more scalable than OSPF in some scenarios, is a Cisco proprietary protocol and is not the industry standard for interdomain routing in service provider cores, limiting interoperability and vendor choice. Its use would also not align with the typical design principles for a large-scale service provider backbone. The professional reasoning process for making such a decision should involve a thorough evaluation of the network's requirements, including scale, traffic patterns, security needs, and operational complexity. This evaluation should be followed by a comparative analysis of routing protocols based on their technical capabilities, scalability, robustness, industry adoption, and operational manageability. Professionals should consult relevant Cisco documentation and industry standards to inform their decision. The ultimate choice should prioritize stability, scalability, and the ability to meet current and future service demands, ensuring the network's integrity and the quality of service provided to customers. Question 12. Cost-benefit analysis shows that a new, more efficient routing protocol offers significant potential for reduced operational overhead and improved convergence times. However, the existing protocol is well understood, has a proven track record of stability, and the operational teams are highly proficient in its management. What is the most professionally responsible approach to adopting this new protocol? Option A. Immediately deploy the new protocol across the entire core network to realize the full benefits as quickly as possible. Option B. Prioritize the adoption of the new protocol based solely on its projected cost savings, assuming that operational teams can adapt quickly to any challenges. Option C. Conduct a pilot deployment in a lab environment and a small, non-critical production segment, with rigorous monitoring and a well-defined rollback plan, before considering wider adoption. Option D. Postpone the adoption of the new protocol indefinitely due to the inherent risks associated with introducing new technologies into a critical network infrastructure. Correct answer is C. Conduct a pilot deployment in a lab environment and a small, non-critical production segment, with rigorous monitoring and a well-defined rollback plan, before considering wider adoption. Explanation. Scenario analysis. This scenario presents a common challenge in service provider network core technologies, balancing the immediate need for network resilience with the long-term strategic goals of adopting new, more efficient technologies. The challenge lies in the inherent risk associated with introducing novel solutions into a critical infrastructure where downtime can have significant financial and reputational consequences. The decision maker must weigh the potential benefits of a new protocol against the proven stability and established operational procedures of the current one, all while considering the impact on service availability and customer satisfaction. The pressure to innovate and reduce operational costs must be carefully balanced against the imperative to maintain a robust and reliable network. Correct approach analysis. The correct approach involves a phased, controlled deployment of the new protocol, starting with a limited scope and rigorous monitoring. This aligns with best practices in network engineering and operational risk management. By initially deploying in a lab environment or a non-critical segment of the network, the team can validate its performance, identify potential interoperability issues, and refine configuration and troubleshooting procedures without jeopardizing the production environment. This iterative approach allows for early detection of unforeseen problems and provides opportunities for correction before widespread implementation. The emphasis on comprehensive testing, documentation, and rollback plans ensures that the network's stability is prioritized throughout the transition. This methodical process minimizes risk and maximizes the likelihood of a successful and beneficial technology adoption. Incorrect approach is analysis. Implementing the new protocol directly into the core network without prior validation in a controlled environment is a significant regulatory and ethical failure. It demonstrates a disregard for operational stability and service availability, which are paramount in service provider networks. This approach exposes the network to an unacceptable level of risk, potentially leading to widespread service disruptions, financial losses for the provider and its customers, and severe reputational damage. It violates the implicit and explicit trust placed in the service provider to deliver reliable connectivity. Choosing to delay the adoption indefinitely based solely on the perceived risk of the new protocol, without any attempt at evaluation or mitigation, is also professionally unsound. While risk aversion is important, stagnation can lead to competitive disadvantage, increased operational costs due to outdated technology, and an inability to meet future service demands. This approach fails to uphold the professional responsibility to explore and implement advancements that could improve network efficiency and service quality. Focusing solely on the cost savings of the new protocol without adequately assessing its operational impact and potential risks is a flawed decision-making process. Financial considerations are important, but they must be secondary to network integrity and service continuity. This approach prioritizes short-term financial gains over long-term network health and customer trust, which is a critical ethical and professional failing. Professional reasoning. Professionals should employ a structured decision-making framework that prioritizes risk assessment and mitigation. This involves 1. Clearly defining the problem and the objectives of any proposed solution. 2. Identifying all potential solutions and their associated benefits and drawbacks. 3. Conducting a thorough risk assessment for each solution, considering technical feasibility, operational impact, security implications, and potential for service disruption. 4. Developing a detailed implementation and rollback plan for any chosen solution, including comprehensive testing and monitoring strategies. 5. Evaluating solutions based on a holistic view of cost, benefit, risk, and strategic alignment, rather than focusing on a single metric. 6. Ensuring all decisions are documented and communicated transparently to relevant stakeholders. 7. Adhering to industry best practices and any applicable regulatory guidelines for network operations and technology deployment. Question 13. Benchmark analysis indicates that a service provider is considering the implementation of segment routing, SR, with an MPLS data plane to enhance network scalability and simplify traffic engineering. The network currently utilizes extensive MPLS LDP and RSVPTE for traffic management. What is the most prudent approach to introducing SR into this existing operational environment to ensure network stability and minimize service disruption? Option A. Prioritize the technical configuration of SR and assume operational teams will adapt to managing the new technology as it is deployed. Option B. Immediately deploy SR across the entire core network to leverage its benefits and address scalability concerns as quickly as possible. Option C. Implement SR only in a dedicated lab environment to validate its functionality without any impact on the live network. Option D. Conduct extensive lab testing of SR configurations and protocols, followed by a phased pilot deployment in a non-critical segment of the production network, with comprehensive monitoring before a full rollout. The correct answer is D. Conduct extensive lab testing of SR configurations and protocols, followed by a phased pilot deployment in a non-critical segment of the production network, with comprehensive monitoring before a full rollout. Explanation. Scenario analysis. This scenario presents a common challenge in service provider networks where the introduction of new technologies, specifically segment routing, SR, with MPLS data planes, must be carefully evaluated against existing operational procedures and potential impacts on network stability and performance. The challenge lies in balancing the benefits of SR, such as simplified provisioning and improved scalability, with the need to ensure seamless integration and avoid service disruptions. A rushed or poorly planned deployment could lead to unforeseen issues, impacting customer experience and potentially violating service-level agreements, SLAs. The decision-making process requires a thorough understanding of SR's operational characteristics and its interaction with the existing network infrastructure. Correct approach analysis. The correct approach involves a phased deployment strategy that includes comprehensive lab testing, pilot deployments in non-production or low-impact segments, and rigorous monitoring. This aligns with best practices for introducing significant network changes. From a regulatory and operational perspective, this methodical approach minimizes risk. It allows for the validation of SR's behavior under various conditions, identification of potential interoperability issues with existing MPLS LDP or RSVPTE, and the fine-tuning of configurations before impacting live services. This proactive stance is crucial for maintaining network integrity and meeting the implicit regulatory expectation of reliable service delivery, even without explicit service provider regulations being detailed for this exam. The focus is on operational excellence and risk mitigation, which are foundational to responsible network management. Incorrect approach is analysis. Implementing SR directly into the production network without prior validation in a lab or pilot environment represents a significant operational and ethical failure. This approach disregards the potential for unforeseen bugs, configuration errors, or performance degradation that could lead to widespread service outages. Such a failure to exercise due diligence would be professionally unacceptable, as it prioritizes speed over reliability and customer impact. Deploying SR only in a lab environment but failing to conduct a pilot deployment on a segment of the live network before a full rollout is also problematic. While lab testing is essential, it cannot fully replicate the complexities and real-world traffic patterns of a production network. This approach misses the opportunity to identify issues that only manifest under live traffic conditions, thereby increasing the risk of unexpected problems during the full deployment. Focusing solely on the technical advantages of SR and overlooking the operational readiness and training requirements for network engineers is another failure. Even a technically sound deployment can falter if the operational staff is not adequately prepared to manage, troubleshoot, and maintain the new technology. This oversight can lead to prolonged downtime and an inability to effectively resolve issues, impacting service availability and customer satisfaction. Professional reasoning. Professionals should adopt a risk-based decision-making framework when introducing new technologies. This involves 1. Thorough understanding of the technology and its implications. 2. Comprehensive risk assessment, identifying potential failure points and their impact. 3. Phased implementation plan with clear go/no-go criteria at each stage. 4. Robust testing and validation strategy, including lab, pilot, and production monitoring. 5. Adequate training and documentation for operational teams. 6. Continuous monitoring and performance evaluation post-deployment. This structured approach ensures that technological advancements are integrated responsibly, prioritizing network stability, service continuity, and customer trust. Question 14. The evaluation methodology shows that when designing a new service provider network segment to isolate customer traffic for enhanced security and compliance, which of the following approaches best aligns with professional network engineering best practices and operational integrity? Option A. Deploy segmentation by creating separate physical interfaces for each customer, regardless of the scale or complexity of the network. Option B. Implement segmentation using VRFs and access control lists, followed by comprehensive testing of traffic flows and security policies before full deployment. Option C. Apply segmentation based on the IP address ranges of the customers, without detailed traffic flow analysis to quickly isolate them. Option D. Utilize VLAN to segment traffic, assuming that logical separation is sufficient for all security and compliance needs, without further configuration. The correct answer is B. Implement segmentation using VRFs and access control lists, followed by comprehensive testing of traffic flows and security policies before full deployment. Explanation. The evaluation methodology shows that understanding the nuances of network segmentation and its impact on security and compliance is paramount for service provider network engineers. This scenario presents a professional challenge because implementing network segmentation without a thorough understanding of its implications can lead to unintended consequences, such as compromising sensitive data, violating regulatory requirements, or degrading network performance. The engineer must balance the need for isolation with the operational requirements of the network. The correct approach represents best professional practice because it prioritizes a systematic and documented process. This involves clearly defining the security zones, understanding the traffic flows between them, and selecting appropriate segmentation technologies, e.g., VRF, VLAN, firewalls, based on the specific security and compliance needs. This approach ensures that segmentation is implemented effectively, minimizing risks and maximizing the benefits of isolation. It aligns with general IT best practices for security architecture and operational integrity, which are implicitly expected in professional environments governed by standards like those Cisco's SPCOR exam aims to assess. While the SPCOR exam itself doesn't mandate specific country regulations, the principles of secure network design and operational efficiency are universally applicable and form the basis of professional conduct. An incorrect approach that involves implementing segmentation based solely on perceived operational convenience without a security review would be professionally unacceptable. This failure stems from a disregard for potential security vulnerabilities introduced by improper segmentation, which could lead to unauthorized access to sensitive data or systems. This is a direct ethical failure, as it prioritizes expediency over the fundamental responsibility to protect network resources and data. Another incorrect approach, implementing segmentation without considering the impact on legitimate traffic flows, would lead to network performance degradation and service disruption. This is a failure in operational competence and can have significant business implications, impacting customer satisfaction and potentially leading to contractual breaches. While not a direct regulatory violation in itself, it demonstrates a lack of due diligence and professional responsibility in managing critical network infrastructure. A third incorrect approach, implementing segmentation without proper documentation and testing, would create a black box scenario. This makes troubleshooting difficult, increases the risk of misconfigurations, and hinders future network evolution. This represents a failure in professional process and adherence to established IT operational standards, making the network harder to manage and secure over time. Professionals should employ a decision-making framework that begins with a clear understanding of requirements, security, compliance, performance. This is followed by a design phase where potential solutions are evaluated against these requirements, considering trade-offs. Implementation should be phased, with rigorous testing and validation at each stage. Finally, ongoing monitoring and documentation are crucial for maintaining the integrity and effectiveness of the network design. Question 15. System analysis indicates that a service provider is planning to introduce segment routing, SR, with an MPLS data plane into its core network to enhance traffic engineering capabilities and simplify network operations. Before proceeding with the implementation, what is the most critical step to ensure compliance with U.S. telecommunications regulations and maintain service integrity? Option A. Deploy SR in a limited segment of the network and observe its performance without a formal assessment of its broader operational and regulatory implications. Option B. Conduct a comprehensive impact assessment evaluating SR's effects on existing routing protocols, traffic patterns, network resilience, security configurations, and service-level agreements. Option C. Proceed with the SR implementation and rely on existing network monitoring tools to detect any operational anomalies or service degradations. Option D. Prioritize the technical advantages of SR, such as reduced overhead, and assume that security and compliance aspects will be addressed post-deployment. The correct answer is B. Conduct a comprehensive impact assessment evaluating SR's effects on existing routing protocols, traffic patterns, network resilience, security configurations, and service-level agreements. Explanation: scenario analysis. This scenario presents a common challenge in service provider networks where the introduction of new technologies, such as segment routing, SR, with MPLS data plane, can have cascading impacts on existing operational processes and compliance postures. The professional challenge lies in ensuring that the implementation of SR does not inadvertently violate established service-level agreements, SLAs, introduce security vulnerabilities, or disrupt critical business functions, all while adhering to the specific regulatory framework governing telecommunications in the United States. The need for a thorough impact assessment stems from the interconnected nature of network services and the potential for unforeseen consequences. Correct approach analysis. The correct approach involves a comprehensive impact assessment that systematically evaluates the effects of SR implementation on all relevant aspects of the service provider's operations. This includes analyzing potential changes to traffic patterns, routing behavior, network resilience, security configurations, and operational procedures. The assessment must also consider the implications for existing SLAs, ensuring that the new technology does not lead to service degradation or breaches. From a regulatory perspective in the U.S., this aligns with the Federal Communications Commission's (FCC) oversight of telecommunications services, which emphasizes reliability, security, and the provision of services in accordance with established agreements. A proactive and thorough assessment demonstrates due diligence in maintaining service integrity and compliance. Incorrect approach is analysis. Implementing SR without a detailed impact assessment on existing routing protocols and traffic engineering mechanisms is a significant regulatory and ethical failure. This approach risks disrupting established traffic flows, potentially violating SLAs and leading to service outages, which would be a direct contravention of the FCC's mandate for reliable service provision. Deploying SR and assuming that existing monitoring and troubleshooting tools will automatically adapt without verification is also professionally unsound. This oversight can lead to delayed detection of issues, prolonged service disruptions, and an inability to meet reporting requirements mandated by regulatory bodies. It represents a failure in operational readiness and a disregard for the need to validate system compatibility. Focusing solely on the technical benefits of SR, such as reduced overhead or simplified configuration, without considering its impact on network security and compliance, is another critical failure. This narrow focus can introduce new attack vectors or weaken existing security postures, potentially violating cybersecurity regulations and jeopardizing customer data, which is a serious ethical and legal concern. Professional reasoning. Professionals should adopt a structured, risk-based approach to technology implementation. This involves 1. Defining the scope of the change and identifying all potentially impacted systems and services. 2. Conducting a thorough impact assessment, including technical, operational, security, and business considerations. 3. Engaging relevant stakeholders, including network engineering, operations, security, and business units. 4. Developing a detailed implementation plan that includes rollback procedures and contingency measures. 5. Performing rigorous testing and validation in a lab environment before production deployment. 6. Establishing clear monitoring and alerting mechanisms to detect and respond to issues post-implementation. 7. Regularly reviewing and updating operational procedures and training to reflect the new technology. This systematic process ensures that new technologies are integrated responsibly, minimizing risks and maintaining compliance with all applicable regulations. Question 16. The monitoring system demonstrates a sustained increase in packet loss on a critical peering link. Without immediate investigation, what is the most appropriate next step to assess the potential impact on customer services? Option A. Classify the alert as a low-priority event and schedule a review during the next maintenance window, assuming it is a transient issue. Option B. Correlate the packet loss alert with traffic volume, error counters on adjacent interfaces, and the health status of upstream and downstream devices to determine the scope and severity of the issue. Option C. Focus exclusively on the packet loss metric on the peering link, assuming it is the sole indicator of the problem's impact. Option D. Immediately initiate a rollback of the last configuration change applied to the affected peering router to revert to a known stable state. The correct answer is B. Correlate the packet loss alert with traffic volume, error counters on adjacent interfaces, and the health status of upstream and downstream devices to determine the scope and severity of the issue. Explanation. This scenario presents a professional challenge due to the critical nature of network stability for service provider operations. The monitoring system's alert, indicating a potential impact on a core service, necessitates a rapid and accurate assessment to prevent widespread customer disruption. The challenge lies in distinguishing between a minor anomaly and a significant issue that requires immediate intervention, balancing the need for swift action with the risk of unnecessary service degradation or outage caused by misdiagnosis. The correct approach involves a systematic impact assessment that prioritizes understanding the scope and severity of the detected anomaly. This means correlating the alert with other relevant network telemetry, such as traffic patterns, error rates, and device health metrics, across the affected service path. By analyzing these correlated data points, engineers can determine if the anomaly is isolated, affecting a specific customer segment, or if it has the potential to cascade and impact a broader user base or critical network functions. This methodical approach ensures that any subsequent actions are targeted, proportionate, and based on a comprehensive understanding of the potential consequences, thereby upholding the service provider's commitment to reliable service delivery and adherence to service-level agreements, SLAs. An incorrect approach would be to immediately initiate a broad network rollback or configuration change without a thorough impact assessment. This is professionally unacceptable because it risks causing a larger, more disruptive outage than the initial anomaly. Such an action bypasses the established incident management protocols designed to ensure that changes are controlled and their impact is understood. It also fails to meet the ethical obligation to provide a stable and reliable service, potentially leading to customer dissatisfaction and breaches of contractual obligations. Another incorrect approach is to dismiss the alert as a false positive without further investigation. This is ethically and professionally unsound, as it ignores potential service degradation that could be impacting customers, even if not immediately obvious. It demonstrates a lack of diligence and a failure to proactively manage network health, which can lead to a loss of customer trust and reputational damage. A third incorrect approach is to focus solely on the originating device of the alert without considering the broader service path. This limited scope of investigation can lead to misidentification of the root cause and the implementation of ineffective solutions, prolonging the issue and its impact on customers. It fails to acknowledge the interconnected nature of service provider networks and the potential for issues to manifest in unexpected ways. The professional decision-making process for similar situations should involve a structured incident response framework. This framework typically includes detection, initial assessment including impact analysis, diagnosis, resolution, and verification. Professionals must be trained to utilize network monitoring tools effectively, understand the interdependencies of network components, and apply critical thinking to differentiate between symptoms and root causes. Prioritizing actions based on potential customer impact and network stability is paramount. Question 17. The efficiency study reveals that a recurring network performance degradation issue in the core service provider network is impacting customer experience. A proposed solution involves a configuration change on a critical router, which, if implemented incorrectly, could lead to widespread service disruption. The operations team is under pressure to resolve the issue quickly. Which approach best balances the need for rapid resolution with operational stability and risk mitigation? Option A. Roll back the network to a previous stable configuration, assuming the issue is related to recent changes, and defer the investigation of the proposed solution until after normal business hours. Option B. Immediately implement the proposed configuration change on the critical router, as the urgency of customer impact outweighs the need for extensive pre-implementation analysis. Option C. Conduct a comprehensive impact assessment involving relevant engineering and operations teams to evaluate the proposed configuration change's potential effects on network stability, security, and performance before proceeding with implementation. Option D. Rely on the experience of the senior network engineer who proposed the solution and implement the change without further validation, given their proven track record. The correct answer is B. Immediately implement the proposed configuration change on the critical router, as the urgency of customer impact outweighs the need for extensive pre-implementation analysis. Explanation. This scenario presents a common challenge in network operations, balancing the immediate need for service restoration with the long-term implications of network changes. The professional challenge lies in making a decision that minimizes immediate disruption while adhering to established operational procedures and potential regulatory compliance requirements, even if those are not explicitly detailed in the SPCOR exam syllabus itself, as the exam focuses on the technical implementation and operation within a given framework. The core of the challenge is risk assessment and the application of change management principles. The correct approach represents best professional practice because it prioritizes a structured and documented process for evaluating the impact of a proposed solution. This aligns with general IT best practices and the implicit need for accountability and auditability in network operations, which are foundational to any regulatory framework. By involving relevant stakeholders and performing a thorough impact assessment, the network operator ensures that all potential consequences, technical, operational, and even security-related, are considered before implementation. This proactive stance minimizes the risk of unintended consequences, service degradation, or security vulnerabilities, all of which could have significant operational and potentially compliance-related repercussions. An incorrect approach that bypasses formal impact assessment and directly implements a fix without proper vetting is professionally unacceptable. This failure represents a disregard for established operational procedures and a lack of due diligence. Such an action could lead to unforeseen network instability, security breaches, or conflicts with existing configurations, all of which could have downstream effects that are difficult to trace and rectify. Ethically, it demonstrates a lack of responsibility towards maintaining a stable and secure network environment for all users. Another incorrect approach, which involves implementing a fix based solely on anecdotal evidence or the opinion of a single individual without broader validation, is also professionally unsound. This approach lacks the rigor required for critical infrastructure management. It introduces a high risk of introducing new problems or failing to address the root cause effectively. This can lead to repeated incidents, increased downtime, and a loss of confidence in the operational team. The professional reasoning process for such situations should involve a clear understanding of the incident's severity, the urgency of resolution, and the available resources. A structured approach would typically involve 1. Incident triage and initial assessment. Quickly understand the scope and impact of the issue. 2. Solution identification and evaluation. Brainstorm potential solutions. 3. Impact assessment. For each potential solution, analyze its technical, operational, and security implications. This is where the correct approach excels. 4. Stakeholder consultation. Engage relevant teams, e.g., operations, security, engineering. 5. Change management. Follow established procedures for proposing, approving, and implementing changes. 6. Post-implementation verification. Monitor the network to ensure the fix is effective and has not introduced new issues. This systematic process ensures informed decision-making and minimizes risk. Question 18. Risk assessment procedures indicate that the introduction of segment routing with an MPLS data plane into the core network requires a thorough evaluation of its potential effects. Which of the following approaches best addresses the comprehensive impact assessment necessary for a successful and compliant deployment? Option A. Focused assessment of how segment routing's traffic engineering capabilities can be leveraged to improve existing MPLS-TE tunnels with minimal disruption to current operational workflows. Option B. A detailed review of segment routing's technical specifications and a validation of its configuration syntax against Cisco best practices, followed by a pilot deployment in a lab environment. Option C. A comprehensive impact assessment encompassing technical compatibility with existing protocols and hardware, operational procedure updates, monitoring and troubleshooting tool adjustments, security implications, and a robust rollback strategy. Option D. An immediate deployment of segment routing across the core network, relying on vendor support and real-time troubleshooting to address any emergent issues. The correct answer is B. A detailed review of segment routing's technical specifications and a validation of its configuration syntax against Cisco best practices, followed by a pilot deployment in a lab environment. Explanation. Scenario analysis. This scenario presents a common challenge in service provider networks where the introduction of new technologies, like segment routing, SR, with MPLS data plane, can have cascading impacts on existing operational processes and security postures. The challenge lies in balancing the benefits of SR, e.g., simplified network configuration, traffic engineering, with the potential risks of misconfiguration, interoperability issues, and the need for updated operational procedures. A thorough impact assessment is crucial to proactively identify and mitigate these risks before deployment, ensuring network stability, performance, and compliance with service-level agreements, SLAs. The professional challenge is to move beyond a superficial understanding of SR and delve into its practical implications across the entire operational lifecycle. Correct approach analysis. The correct approach involves a comprehensive, multifaceted impact assessment that considers technical, operational, and security dimensions. This includes evaluating the compatibility of SR with existing routing protocols, e.g., BGP, OSP, its interaction with MPLS traffic engineering mechanisms, and the necessary modifications to network monitoring and troubleshooting tools. Furthermore, it necessitates a review of operational runbooks, training requirements for network engineers, and the development of robust validation and rollback procedures. This holistic approach aligns with best practices for network change management and risk mitigation, ensuring that the deployment of SR is controlled, predictable, and minimizes disruption to services. From a regulatory perspective, while the SPCOR exam does not specify a particular jurisdiction's laws, the underlying principle of due diligence in network operations, ensuring service reliability and security, is universally expected. A thorough impact assessment demonstrates a commitment to operational excellence and adherence to implicit industry standards for network stability. Incorrect approaches analysis, focusing solely on the technical configuration of SR without considering its operational and security implications, represents a significant regulatory and ethical failure. This narrow focus ignores the potential for misconfigurations to impact service availability, leading to SLA breaches and customer dissatisfaction. It also overlooks security vulnerabilities that might arise from improper SR implementation, such as traffic leakage or denial of service vectors. Prioritizing the immediate benefits of SR, e.g., faster deployment of new services, over a detailed impact analysis is professionally irresponsible. This approach risks introducing unforeseen problems that could outweigh the initial advantages, potentially leading to costly remediation efforts and reputational damage. It demonstrates a lack of foresight and a disregard for the principles of controlled network evolution. Implementing SR based on vendor documentation alone, without independent validation and consideration of the specific network environment, is another failure. Vendor documentation is a guide, not a substitute for understanding the unique characteristics and existing configurations of the service provider's network. This can lead to interoperability issues and unexpected behavior, compromising network stability. Professional reasoning. Professionals should adopt a structured, risk-based approach to network changes. This involves 1. Defining the scope of the change and its objectives. 2. Identifying potential risks across technical, operational, and security domains. 3. Assessing the likelihood and impact of each identified risk. 4. Developing mitigation strategies and contingency plans. 5. Documenting the assessment and the approved plan. 6. Implementing the change in a controlled manner with thorough testing and validation. 7. Conducting a post-implementation review to capture lessons learned. This systematic process ensures that changes are made with a clear understanding of their implications and that potential disruptions are minimized, upholding professional responsibility and service integrity. Question 19. Process analysis reveals that a critical security patch needs to be deployed across the core service provider network. This patch addresses a vulnerability that could lead to significant service degradation and data compromise if exploited. The deployment involves changes to routing protocols and quality of service (QoS) configurations on multiple high-capacity routers. What is the most appropriate approach to ensure the successful and safe implementation of this critical patch? Option A. Conduct a comprehensive impact assessment that includes evaluating potential effects on service availability, performance, security, and operational complexity, and develop a detailed rollback plan. Option B. Perform a limited impact assessment focusing only on the immediate routing protocol changes on the affected routers. Option C. Deploy the patch during a scheduled maintenance window without a formal impact assessment, assuming minimal disruption due to the patch's nature. Option D. Proceed with the deployment immediately to mitigate the security risk as quickly as possible, relying on the vendor's release notes for guidance. The correct answer is A. Conduct a comprehensive impact assessment that includes evaluating potential effects on service availability, performance, security, and operational complexity, and develop a detailed rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge in service provider network operations: the need to implement significant network changes while minimizing disruption to critical services. The professional challenge lies in balancing the urgency of implementing new features or security patches with the absolute requirement of maintaining service availability and performance for customers. Failure to adequately assess the impact of a change can lead to widespread outages, financial losses, reputational damage, and potential regulatory scrutiny if service-level agreements, SLAs, are breached. The complexity is amplified by the interconnected nature of modern service provider networks, where a seemingly minor change in one area can have cascading effects elsewhere. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously analyzes the potential consequences of the proposed network change across all relevant domains. This includes evaluating the impact on service availability, performance metrics, latency, jitter, throughput, security posture, operational complexity, and customer experience. A key element of best professional practice is the development of a detailed rollback plan, ensuring that the network can be quickly and safely returned to its previous state if the change proves detrimental. This proactive and thorough methodology aligns with industry best practices and the implicit ethical obligation of service providers to deliver reliable services. While the SPCOR exam focuses on technical implementation, the underlying principle of responsible change management is paramount. Incorrect approaches analysis. Implementing the change without a formal impact assessment is a direct violation of sound operational principles and carries significant ethical and professional risks. It demonstrates a disregard for potential consequences and customer impact, which is professionally unacceptable. This approach could lead to unforeseen service disruptions, breaching SLAs, and potentially incurring penalties or legal liabilities. Performing a superficial impact assessment that only considers the immediate technical impact on the directly affected devices, while ignoring downstream dependencies or performance implications, is also professionally deficient. This limited scope fails to capture the full picture of potential risks, leaving the network vulnerable to unexpected issues. Ethically, it represents a failure to exercise due diligence in protecting service continuity. Relying solely on the vendor's documentation for impact assessment, without independent verification or consideration of the specific network environment, is another flawed approach. Vendor documentation may not account for unique configurations, existing network conditions, or specific customer traffic patterns. This can lead to an incomplete understanding of the risks, increasing the likelihood of negative outcomes and demonstrating a lack of independent professional judgment. Professional reasoning. Professionals should adopt a structured change management process that mandates a thorough impact assessment before any significant network modification. This process should include defining the scope of the assessment, identifying all potential areas of impact, consulting relevant stakeholders, operations, engineering, customer support, developing mitigation strategies, and creating a detailed rollback plan. The decision to proceed with a change should be based on a clear understanding of the risks and a demonstrated ability to manage them effectively. This systematic approach ensures that technical decisions are made with a holistic view of service delivery and customer impact, upholding professional standards and regulatory expectations for service reliability. Question 20. The audit findings indicate that the service provider's change management process lacks a robust mechanism for assessing the potential downstream effects of network configuration, updates on service availability, and performance metrics. Which of the following actions best addresses this audit finding in accordance with industry best practices for service provider operations? Option A. Implement a mandatory, multi-stage impact assessment review involving network engineering, operations, and business stakeholders prior to any significant network change deployment. Option B. Conduct a retrospective analysis of past incidents to identify common causes of service disruption, and use this data to inform future change decisions without a formal pre-change assessment. Option C. Rely on post-implementation monitoring, alerts to identify and address any service degradations that occur after a change is made. Option D. Delegate the responsibility for impact assessment solely to the network automation team to streamline the change process. The correct answer is A. Implement a mandatory multi-stage impact assessment review involving network engineering, operations, and business stakeholders prior to any significant network change deployment. Explanation. The audit findings highlight a critical gap in the service provider's operational procedures concerning the impact assessment of network changes. This scenario is professionally challenging because network changes, even seemingly minor ones, can have cascading effects on service availability, performance, and security. A failure to adequately assess these impacts can lead to significant service disruptions, financial losses, reputational damage, and non-compliance with service-level agreements, SLAs, and potentially regulatory requirements if service continuity is mandated. The core challenge lies in balancing the need for agility in network evolution with the imperative of maintaining stable and reliable service delivery. The correct approach involves a structured and comprehensive impact assessment process that is integrated into the change management lifecycle. This process should systematically identify potential risks, evaluate their likelihood and severity, and define mitigation strategies before any change is implemented. This aligns with best professional practices by prioritizing service stability and customer experience. From a regulatory and ethical standpoint, this proactive approach demonstrates due diligence and a commitment to fulfilling contractual obligations and maintaining the integrity of the network infrastructure, which is crucial for the reliable delivery of essential communication services. An incorrect approach would be to bypass or inadequately perform the impact assessment due to time constraints or perceived low risk. This is professionally unacceptable because it disregards the inherent complexities of interconnected network systems. Specifically, it represents a failure to adhere to established change management best practices, which are often implicitly or explicitly part of industry standards and contractual agreements. Ethically, it breaches the implicit trust placed in the service provider to maintain service continuity and quality. Furthermore, depending on the specific jurisdiction's telecommunications regulations, which for this exam are assumed to be U.S.-centric, focusing on FCC guidelines and general telecommunications law, such negligence could lead to penalties for service disruption or failure to meet mandated uptime requirements. Another incorrect approach is to rely solely on automated tools without human oversight and expert judgment. While automation is valuable, it cannot fully capture the nuanced understanding of business impact, customer sensitivity, or unique network configurations that experienced engineers possess. This approach fails to leverage critical human expertise, increasing the risk of overlooking subtle but significant impacts. The professional decision-making process for similar situations should involve a clear understanding of the organization's change management policy, a thorough risk assessment framework, and a commitment to a culture of continuous improvement. When faced with pressure to expedite changes, professionals must advocate for the adherence to established impact assessment procedures, clearly articulating the potential consequences of deviation. This involves escalating concerns through appropriate channels and documenting any decisions to bypass standard procedures, along with their justifications and accepted risks.